Okay, we're going to continue polynomials. We're going to graph them and talk about some other properties of polynomial functions. All right, so the first thing that we'll discuss is the concept of an end behavior. Now, an end behavior just refers to what happens to the polynomial as you go to the left and as you go to the right. So for instance, if I had, let's say, x squared, right? You guys know that x squared makes this parabola shape, all right? And if you notice, right, the arrows at each end point upwards, right? So these are what represent the end behavior of this polynomial. Another thing that represents the end behavior, or that I can show you guys with the end behavior, is just, I don't know, if I gave you something like 2x plus 5, right? You know that that's a line with a positive slope. It's going to look something like that. And this is a linear function. And then you can see as you go to the left, you're going down. And as you go to the right, you're going up. All right. Another thing that you guys have seen before is an x to the third, right? An x to the third makes this kind of snake shape, right? So it kind of looks something like that. Once again, right, as you're going to the left, you're going down. As you're going to the right, you're going up, right? So that's how we describe an end behavior, right? And really, I could go on and give you something like negative x squared, right? You guys know that that points downwards. And then you have that as on the left, you're going down. On the right, you're also going down, right? So all of these red circles that I'm drawing are really what represent the end behavior. And they don't just happen randomly, right? The end behavior is determined based on the leading term, right? So the leading term in standard form is just the term that has the highest exponent, right? So what you would describe then would be the degree, right? So for example, something like 3x to the third plus 2x squared plus 5x. Hang on, 5x plus 1, right? Something like that. The leading term would be this right here, the 3x to the third, right? And you're looking at the degree, so the highest exponent. So odd degree means that your highest exponent is odd, and the odd degree polynomials are going to have opposite behavior at each end, right? So think odd, opposite, right? O goes with the O, all right? And these notes refer to the letter A as your leading coefficient. If the leading coefficient is positive, then it's going to fall to the left and it's going to rise on the right, right? Anything could happen in between, right? So maybe it makes a shape kind of like that, right? Kind of like a rough sketch, but what we know for sure is that towards the left, it's going to go down, and towards the right, it's going to go up, all right? If A, our leading coefficient, is negative, then the graph is going to rise as you go to the left, and it's going to fall as you go to the right. Again, anything could happen in between. It might go up and then back down and then up and then down. But what we know for sure is that forever and ever to the left, it's going to go up, and forever and ever to the right, it's going to go down. All right. Even degree polynomials have the same behavior at each end, right? So think about like an x squared, right? An x squared is an even degree, right? To the highest exponent is even, and so both ends are going to go up, right? Which you guys already know, right? Because it makes a parabola, all right? And then if A, your leading coefficient, is positive, then both ends are going to point up, so up and up. And then if A, your leading coefficient, is negative, both ends are going to go down, right? So down and down, all right? There's really only 4 cases with end behavior. It's either opposite directions, where the left is up, right is down, or left is down, right is up, or they're in the same direction where both are up, both are down, right? I kind of like to summarize it in a little chart, right? And on one side, I have the degree, and then on the other side, I have the leading coefficient, right? And the degree is either odd or even, and then the leading coefficient is either positive or negative, all right? Odd positive is going to mean the left is going to go down, the right is going to go up. Odd negative means it's just going to be the opposite, right? The left is going to go up, the right is going to go down. even positive, right, both ends are going to go up, and then even negative, both ends are going to go down. All right, so these are the only 4 cases with your end behavior. And if that's confusing right now, don't worry, right? We're going to do a couple examples where you're going to see where this is useful, right? But for now, what you guys should know is that the end behavior is determined based on the leading term, so the highest exponent and the sign of the number in front of it, all right? Next slide, we're going to discuss zeros and multiplicity. You guys already know the concept of zeros, right? We've done it a bunch of times already, right? So we just set our function equal to 0. Another word for zeros are roots or solutions. And they also appear as x-intercepts, right? So really I could give you any of those and it would mean the same thing, all right? One thing that I talked about in the previous lesson, kind of briefly, is the concept of a multiplicity, right? So a multiplicity just is the number of times that a root occurs. So for example, if I have x minus 1 squared, that just means x minus 1 is a factor twice, and so that means x equals 1 is an answer twice, right? So I would say x equals 1 with a multiplicity of 2, all right? That's going to have its uses in graphing, right? Just because it's going to tell you what happens at the x-axis, right? What behavior it has. If the multiplicity is even, then the graph is going to touch and turn. So it's just going to hit the x-axis and it's going to turn. So for example, let's just say I have x equals 1 multiplicity of 2, right? I'll take this right here, right? You guys know that that is a quadratic function. It's going to make a parabola shape. And at x equals 1, it's going to kind of go down, and then it's going to touch it, and then it's going to turn around, right? So then it's going to go kind of like that. Notice that it doesn't go through the x-axis, it just touches it and it bounces back, all right? Now, if the multiplicity is odd, so meaning, let's say I just have, I don't know, x plus 1 as my function, right? That's just a line. All you're going to do is cross the x-axis, right, when you're graphing, all right? So odd multiplicities cross, right? So if I had something like this, it would cross somewhere right there, right? You guys know that plus in your function is going to go in the opposite direction. And it goes 1 up as well, right? So something like that. And then notice at this point right here, it crosses, right? It doesn't go, it doesn't touch and turn. It actually goes through the x-axis, right? Again, if that concept is a little confusing, don't worry, we're going to do a couple examples where we're gonna tie everything together pretty nicely. All right, here's some strategies for graphing, right? The rest of these examples are gonna be graphs. The most important thing, well, all of this is pretty important, but the biggest thing that some people might miss is determining the end behavior. All right, so your end behavior should make sense also with your zeros and your multiplicity, right? So you want to know what happens to the very left and to the very right, and finding the zeros and the multiplicity help you find out what happens in between the left and the right, right? Finding the y-intercept just helps you get an additional point. If you need more points to make the picture a little bit clearer, you can find additional points. I will say for the sake of this class, the most important thing is determining these first 3, right? You can pick additional points if you want. It's not super, super important for this class as long as you have the right shape of the graph. All right, so let's try something like this. We have a lot of information that we need to find, but let's just take it one at a time, right? So the first thing is determining the end behavior. All right, to find the end behavior, we look at the leading term, right? So whatever has the highest exponent. And in this case, x to the 3rd has your highest exponent, right? And I know that my degree is 3, which is odd, right? So my degree is odd. And the sign of your leading coefficient, right? If you don't see a number, assume it's a 1. The sign is positive. I don't really care about the number itself. I just care about if it's positive or negative. All right, positive Again, remember, odd opposite means that they're going to go in opposite directions, and odd positive happens to go down and then up. All right, and you can write it just like that, right? If it's, let's say, a free response question on a test or a quiz, that's perfectly fine. In words, right, let's say you have options to choose from. You can say it falls left and rises to the right. So falls left, rises right, right? That's perfectly fine, all right? And that just means on this graph, somewhere over here, we're gonna go down forever and ever, and then somewhere up here, we're gonna go up forever and ever, all right? I'll figure out what happens in between as we go along, but I just know for sure that that's what's gonna happen at the ends, all right? Now let's find the zeros, all right? To find the zeros, I'm going to first check if we can factor it, right? It has 4 terms, but notice if you try grouping it, it doesn't factor nicely, right? So we're gonna have to do synthetic division with possible rational roots, right? So I first wanna make a list of my possible roots, right? This was the previous lesson. My possible roots are gonna be plus minus 1, 2, 3, and 6, right? I got those numbers from this last number, right? Factors of 6 over factors of 1, right? And anything over 1 is itself, so I'm just gonna leave it as 1, 2, 3, and 6, all right? Now we guess, right? So I'm gonna use 1, the easiest number. And in my synthetic division, I'm gonna do 1, negative 2, negative 5, and 6. All right, and then bring down 1. 1 times 1 is 1, negative 2 plus 1 is negative 1, times 1 is negative 1, minus 5 is negative 6, times 1 is negative 6, and we get 0, right? And that means that this number is a 0 of our polynomial, right? So I'm gonna say x equals 1 is one of our zeros. Now I know for sure the graph is gonna touch that point somewhere, so I'm just gonna plot it as we go along, right? Just plot that point, all right? So we got it first try, right? Pretty lucky. All right, now we take these numbers and we turn that into a quadratic function, right? So this becomes x squared minus x minus 6 equals 0. And then we need factors of negative 6 that add to negative 1. So this is going to be x minus 3, x plus 2 equals 0. All right, and that just means my other two zeros are going to be x equals 3 and x equals negative 2. All right, so let me list those out. X equals 3 and x equals negative 2, right? And I'll plot those on the graph. Negative 2 is right here, and then 3 is right there. All right, and then those are all of our answers, right? So now let's try to find the multiplicity of each zero. Again, multiplicity just means the number of times each solution occurs. And in this case, we have 3 answers and we got all of them once. So I'm gonna say they all have a multiplicity of 1, right? Now the behavior at the x-axis is determined from the multiplicity, all right? So because 1 was the multiplicity for all of my zeros, and 1 is an odd number, then I'm gonna say all the zeros have to cross, right? Remember, odd multiplicity means you cross the x-axis. Whoa, that doesn't look good, hold on. Odd means we cross, all right? If it was an even number, like let's say one of them had a multiplicity of 2, that would mean we have to touch and turn or bounce, right? And then, yeah, okay, so lastly, our y-intercept, this is where we plug in 0 for x, right? So I want to plug in f of 0, and we get 0 to the third, minus 2 times 0 squared, minus 5 times 0 plus 6, right? All of these are going to turn to 0, and we're just left with 6, all right? So our y-intercept as an ordered pair is going to be 0, 6. Another way that we can do that, in standard form, it's always going to be this last number, right, including the sign, right? So if it's a positive 6 at the end, then that's our y-intercept, right? So pretty easy. I'll plot that point on the graph. And we filled out all of our information. This is actually enough information to sketch our graph, right? So I know at the very left, we have to go down. And at the very right, we have to go up, right? So that accounts for the end behavior, right? Let me erase that. All right. And then I know that at all of the zeros, we're going to have to cross, right? So I'm going to cross x equals -2. I know we have to touch the y-intercept at some point, come back down. I know that at 1 had a multiplicity of 1, so I have to cross it. And then at some point I have to come back up and then cross 3 as well. All right, so then this is the final sketch of our graph. All right. It might not be 100% accurate just because, you know, anything could really happen between the x-intercepts, right? I actually think this one goes up a little bit higher on this end. All right, so I think it goes up here somewhere. And then it doesn't, I don't think that it goes this low in between, right? So I think it goes maybe somewhere right here, right? But the only way to know is if you plug in points and test them. But really, for the sake of this class, I just want to make sure that you guys understand the shape, right? Everything in the graph is consistent with the information that we asked of you. But that's it for this one. So let's try the exact same thing over here. All right, so let's first determine the end behavior. Pretty easy, right? We're just looking at the leading term. And again, it's an odd degree. And the leading coefficient is positive. So this is an odd positive. It's also going to be a down and then an up, all right? And again, that's perfectly fine. You can also say it falls to the left, it rises to the right. And right, so now I know that that's what's going to happen to the very left and to the very right. All right, now let's find our zeros. To find our zeros, I do need possible roots, right? So I'm going to write that up here, possible roots. And your possible roots are going to be plus minus factors of the last over the first, right? So factors of 12 are going to be 1, 2, 3, 4, 6, and 12 over factors of the first, which are 1 and 2, all right? You can clean this up a little bit. You can put everything over 1, which is just plus minus 1, 2, 3, 4, 6, and 12, so everything on top. And then if you put everything over 2, the only things that are not going to simplify are 1/2 and 3/2, right? Everything else is going to simplify into something that we already have, right? So these are my options here. We're going to do synthetic division, and you're going to do trial and error, right? You would start with 1 and then go to -1 and then go to 2 and then go to -2, assuming none of them work. I already know what the answer is going to be, so just for the sake of time, I don't want this video to be too long. I'm just going to use the one that I know works, but if you were just doing this on your own, you would pick from 1 and then work your way up, right? But anyway, I know the answer is going to be -3, right? So I'm just going to do -3. We're going to get 2, -1, -25, and -12. All right, and then we're going to get a 2, a -6, -7, 21, -4, 12, and 0, right? So -3 does work, all right? Again, you would do this on your own. You would start from 1 and work your way up, but again, just trying to save a little bit of time. I know that one of my zeros is going to be x equals -3, all right? So I'm going to plot that point. And then now with these leftover numbers, I would write it in quadratic form, so it would be a 2x squared minus 7x minus 4 equals 0, and then you would factor, right? 2 times -4 is going to get you -8, and then factors of -8 that add to -7 are a -8 and a +1. So I know that this is going to be a 2x squared minus 8x plus 1x minus 4 equals 0, and then you can solve it by grouping. All right, I think in class I do the slide and divide, right? That's perfectly fine as well, right? But I'm just showing you another way to do it, right? So 2x and then x minus 4 plus 1, x minus 4 equals 0. And then we get 2x plus 1 and x minus 4 equals 0, all right? And then you set each factor equal to 0, so 2x plus 1 equals 0, and x minus 4 equals 0, and so we should get x equals -1/2 and x equals 4, all right? So then those are my other two zeros, x equals -1/2 and x equals 4, right? And I'll plot those points, right? So negative a half is right there, and 4 is right there, all right? Now the multiplicity of each 0, again, they all show up once, so I'm going to say they all have a multiplicity of 1. And that would mean since 1 is an odd number, the behavior at the x-axis means they're all going to cross. All right? And then your y-intercept, like I mentioned before, is just going to be you're going to take that last number and you're going to put it as an ordered pair, 0, negative 12. All right? To make it fit on the graph, I'm going to make it go by 2's, so negative 2, negative 4, negative 6, negative 8, negative 10, and negative 12, right? So again, just to make it fit. And then we have enough information to sketch our graph, right? I know at the very left, it's going to go down. At the very right, it's going to go up, right? So that's consistent with the end behavior. And then I know that at these x-intercepts, they're going to cross, right? So I'm going to cross, go back down, cross, and then I have to cross the y-intercept. And then eventually I'm going to have to go back up, and then we cross that point as well. All right, so this is the final sketch of our graph, all right? Let's try one more like it. One thing that I noticed in these notes, all of these are cubic functions, so all of these are to the third power. We're going to do plenty of practice outside of class. Well, not outside of class, but outside of these notes that have higher powers, like for instance an x to the fourth, right? So that way we can practice a little bit more of those, right? But you're not only going to see x to the thirds in these kinds of problems. Sometimes you see an x to the fourth, right? The highest we typically go is like an x to the fifth, right? But again, just for the sake of these notes, we're going to keep doing these examples. But again, outside of class, I'm going to do ones with higher exponents, or outside of these notes, sorry. All right, now let's first determine the end behavior. All right, the end behavior, all right, like I just mentioned, this has an exponent of 3, which is odd, and the leading coefficient is a negative number. So this is an odd negative. It's actually going to go up and then down, right? So the opposite of the last two, all right? And now let's find our zeros, all right? So we would test possible rational roots. So plus minus factors of the last are going to be 1, 2, 4, 5, 10, and 20 over factors of the first, which is just 1. But anything over 1 is itself, so I'm going to go ahead and erase this. Right? It's just going to look something like that. And now we pick numbers, right? So let's try 1, and let's see if that works, right? Negative 1, negative 8, negative 11, and 20. All right, so I know negative 1 is going to get us a negative 1, negative 1, negative 9, negative 9, negative 20, negative 20, and 0, right? So this one worked first try. Again, just like the previous example, not always are they going to work first try, but sometimes they do, right? And so I get x equals 1 as one of my answers. I'm going to plot that on the graph, right? Put it right there. And then the next two answers we can get by using these numbers. This is going to get us a negative x squared minus 9x minus 20 equals 0. I don't like that there's a negative in front of the x squared, so I'm going to divide everything by negative 1. All right, and then what that does is that's going to make everything positive. So it's going to be an x squared plus 9x plus 20 equals 0. And then we can factor this as normal. This is going to be x plus 4x plus 5 equals 0. And then we get x equals negative 4 and x equals negative 5. All right, so I'll plot those on the graph right there. And then I'll list them, x equals negative 4 and x equals negative 5. All right. Multiplicity, just like the last two, they're all going to have a multiplicity of 1. And just like the last two, they're all going to cross because 1 is an odd number. And then our y-intercept, we're going to use the last term that I see there, so it's going to be 0, 20. All right, I'll make this one go by 4s, right? So I'll say 4, 8, 12, 16, and 20, right? And so 20 would go right there. All right, and now this is enough information to sketch our graph. I know that because of my end behavior at the very end, this should go up. And at the very end over here, this should go down. And then I know that we're going to cross all of the x-intercepts, so I know it should hit the y-intercept. at some point go down and cross -4, and then at some point cross and go back up at -5, right? So look something like this, right? This graph might not be perfect, but it's consistent with the information that we found. All right. The next two examples are going to be slightly different. I'll show you how we're going to do these, right? So notice that it's not in standard form just like the others, right? This one is actually in factored form already, right? So because it's in factored form, it's easier in some sense because you don't have to do synthetic division at all. But it's slightly challenging in the sense that you're going to have to think a little bit harder to find your end behavior, and then finding your y-intercept, you're actually going to have to do a little bit of work to find it. All right, but I'll show you how to do it, right? It's not so bad. I'll start with finding the zeros, right? So I don't want to find the end behavior just yet, just because it's not super obvious to us right now. But what I'm going to do to find the zeros is we always set our function equal to 0. And doing that is going to set all of these factors equal to 0, right? There is a negative out front, but we'll deal with that later, right? We don't need to set that negative equal to 0. That doesn't really make sense, all right? So I'm just going to take these factors. So x minus 3 squared equals 0, x minus 1 equals 0, and x plus 1 squared equals 0, all right? And x minus 3 squared is the same as saying x minus 3 times x minus 3 equals 0, right? That's what the square means, right? So really, you're going to have two answers that are the same, right? So I have x minus 3 equals 0, x minus 3 equals 0, and so I get x minus 3 and x equals 3. If I get the same answer twice, I only have to write it once, so I'm going to say x equals 3. But what that means is that our multiplicity is going to change, right? I'm going to say x equals 3 has a multiplicity of 2, right? Because it shows up twice, right? That's the only difference with that, right? And then that also means that at the x-axis, x equals 3 is going to bounce. You can also say it's going to touch and turn, all right? Those mean the same thing, right? But I know for sure that it's not going to cross it because 2 is an even number, right? An even multiplicity is always going to touch and turn, all right? Now let's try the same thing with x minus 1, right? This one I can just add 1 to both sides, and I get x equals 1, all right? So I get x equals 1. That one only showed up once, so I'm going to say this has a multiplicity of 1, and I'm going to say x equals 1 because 1 is an odd number. It's going to cross the x-axis, all right? And then lastly, x plus 1 squared equals 0. I know that that means x plus 1 times x plus 1 equals 0. And then so I get x plus 1 equals 0, x plus 1 equals 0. And so really you get the same answer twice again, all right? So then I get my last 0 is x equals -1. And then I'm going to say x equals -1 has a multiplicity of 2. And that just means x equals -1 bounces, all right? Okay, so then that's how we find all that information. That actually helps us find our end behavior, right? Believe it or not. All right, the end behavior is determined based on the highest exponent. But we had also mentioned in the previous lesson that the highest exponent tells you how many answers you should get, right? So you can kind of count how many answers you got here, including their multiplicity, to get your degree. So how many times did we get x equals 3, right? That one had a multiplicity of 2, so I would say that it shows up twice. X equals 1 had a multiplicity of 1, so it shows up once. And x equals -1 also showed up twice, all right? So that just means my total number of zeros is 5, right? So 2 plus 1 plus 2 is going to get you 5. So my end behavior, my degree is odd, right? And it was 5, right? Our degree is 5, which is an odd number. And I'll just say that this is because there are 5 zeros, including their multiplicities. multiplicity. All right, so anytime you have a problem like this, don't jump right into finding the end behavior first, right? I know it's listed first. That doesn't mean you have to find it first, all right? Sometimes it's easier to just find the factors, find the zeros, and then count them, all right? And then you can see now that we have 5 answers, our degree is odd, right? And then we're also going to take into account that negative that was in front. That means the sign is negative. So this is an odd negative. That means it's going to start up and then end down, right? So it's going to be up and then down, our end behavior, all right? So shouldn't be super difficult, right? I didn't do a lot of work to find that, but you did kind of have to think a little bit harder, all right? Same exact thing with the y-intercept, right? To find the y-intercept, it's always f of 0. And so I'm just going to plug in 0 into our function, all right? So I get 0 minus 3 squared, 0 minus 1, and then 0 plus 1 squared, all right? And that's going to get me negative 3 squared times negative 1 times 1 squared, which is negative 9 times negative 1 times 1, which is going to simplify to, well, not negative, positive 9, all right? So 0, 9 is our y-intercept. All right, let's plot all of this on the graph, right? The y-intercept, I'll make it go by 2s, 2, 4, 6, 8, 10. And so it's going to go somewhere right there. And then my intercepts, I'm going to put at negative 1, 1, and 3. All right. And I'm going to use my end behavior to kind of figure out the rest of my graph, right? I know that at the very left, it's going to go up. At the very right, it's going to go down. And I know at negative 1, because it had a multiplicity of 2, it's not going to cross it, it's going to bounce. All right, and then I know I have to cross at the y-intercept, and then eventually I'll have to go back down, right? And at 1, it crosses because it had a multiplicity of 1. And then eventually I'm going to go back up, and we're going to touch and turn at 3 because that one also had an even multiplicity. And then we're going to finish going all the way down, all right? So this is a rough sketch of our graph. Again, we got that just from the information that we already found, right? The hardest part is finding the information. The second hardest thing is interpreting it in a graph, right? But once you put all of it together, you're going to see that these take a long time, but they shouldn't be extremely difficult, right? Maybe a little tedious, but okay, let's try one more, all right? So once again, this is in factored form. What we're going to do if it's in factored form, set these equal to 0. Again, I'm just going to set each of these factors equal to 0. So this is going to be x plus 2 squared equals 0 and x minus 3 squared equals 0. All right, and again, that just means x plus 2 times x plus 2 equals 0. And then if you set each of these equal to 0, you get x equals negative 2 twice, all right? So once again, I'm going to say that one of my zeros is x equals negative 2. And I'm going to say x equals negative 2 has a multiplicity of 2. And I'm also going to say that x equals negative 2 bounces, all right? Because 2 is an even number, all right? Let's do the same thing with x minus 3 squared. That just means x minus 3 times x minus 3 equals 0. And that just means I get x equals 3 twice. So once again, one of my zeros is x equals 3. And this is another one that has a multiplicity of 2. So those are both going to be grouped under that answer. And then this is another one that bounces, right? So they both have a multiplicity of 2. That just means they both bounce, all right? And then for my end behavior, since they each showed up twice, then I get 2 plus 2 is 4. So this is an even degree, and since the sign out front is negative, it's even negative. Even goes in the same direction, so I know that these have to go down and down because it's negative, all right? Lastly, we're going to find the y-intercept, again, just plugging in 0, so f of 0 is going to get you negative 0 plus 2 squared times 0 minus 3 squared, which is going to get you negative 2 squared times negative 3 squared, which is negative 4 times 9, which is negative 36. All right, that means my y-intercept is 0, negative 36. All right, I'll make it go by sixes, so -6, -12, 18, 24, 30, and 36. All right, so I'll plot a point right there. And then I know that my zeros are going to be -2 and a +3. And let's use the end behavior to fill in the rest of our graph, end behavior and multiplicity. So I know at the very left it has to go down, and at the very right it also has to go down since they're both going down in each direction, right, based on our end behavior. All right, and then I also know because of the multiplicity of 2 that they're going to touch and turn. So I know it should look something like that. And then once I go back up, I know that I'm not going to cross that 3, I'm going to touch and turn, and it should look something like that as your final answer. All right, but that's it for this lesson. Again, these are only a few cases of what you might see for these kinds of problems, but hopefully the process gets smoother, right? As you do more of these, the process shouldn't be extremely difficult, it just might be a little bit time consuming, all right?